The signal began at our Sun, traveled billions of kilometers through the solar system, crossed the boundary between everything we call home and the space between the stars, and eventually made the thin ionized gas of interstellar space ring out like a bell. And the strangest part is that humanity has actually detected it. Far beyond the planets, Voyager 1 has been listening to something no human spacecraft had ever experienced before. What scientists discovered in the data is one of the most remarkable stories in the entire history of space exploration. To understand what Voyager 1 is hearing, we first have to understand where this spacecraft actually is. Voyager 1 launched on September 5, 1977, from Cape Canaveral, Florida. At the time, nobody working on the mission could have imagined that this small spacecraft would still be operating nearly 5 decades later. It flew past Jupiter in March 1979 and Saturn in November 1980, sending back extraordinary images of both planets and their moons. After those encounters, Voyager 1 continued outward, using the momentum gained from its planetary flybys to travel deeper into the outer solar system. It passed beyond the orbits of the planets and eventually reached the outermost region controlled by our Sun. Then, on August 25, 2012, something historic happened. At a distance of roughly 121.7 astronomical units from the Sun, or about 18 billion kilometers, Voyager 1 crossed the heliopause. The heliopause is the boundary surrounding the heliosphere, the enormous bubble created by the solar wind and the Sun's magnetic influence. Crossing that boundary meant Voyager 1 had entered interstellar space. It became the first human-made spacecraft to do so. But Voyager didn't stop there. It kept moving. It kept transmitting. And, most importantly for this story, it kept listening. Today, Voyager 1 is roughly 25 billion kilometers from Earth. Its radio signal travels at the speed of light, yet it still takes more than 23 hours to make the journey home. Think about that for a moment. When engineers send a command to Voyager 1, they cannot simply wait a few seconds to see what happens. The spacecraft is so far away that communication is measured in almost an entire day. And yet, somehow, a machine launched in the 1970s is still sending scientific information back to Earth. One of the most important instruments responsible for that information is the plasma wave system, often abbreviated as PWS. The instrument has 2 long antenna rods extending from the spacecraft. But these antennas aren't listening to sound in the ordinary sense. There is no atmosphere in interstellar space. No air is surrounding Voyager. No conventional sound wave could travel through the near vacuum between the stars the way sound travels through air on Earth. So when people say Voyager is hearing interstellar space, that needs a little explanation. The instrument is actually detecting oscillations in electric fields produced by electrons moving through the extremely thin plasma surrounding the spacecraft. Plasma is a state of matter made up of charged particles. And even though interstellar space appears almost completely empty, it isn't truly empty. There are particles scattered through it. Those particles can interact, move, and oscillate. When the plasma vibrates at particular frequencies, Voyager's antennas can detect incredibly tiny electrical signals. Scientists can then take those recorded frequencies and shift them into a range humans can hear. That's how the strange sounds associated with Voyager are produced. They aren't fictional sound effects. They aren't simply computer-generated noises designed to make a documentary more dramatic. They are audio representations of actual measurements collected by an instrument millions of kilometers away. And those measurements tell scientists something extremely valuable. The frequency of the plasma oscillations can be used to estimate the density of the plasma around Voyager. In simple terms, the higher the frequency, the greater the electron density of the surrounding plasma. That relationship comes directly from plasma physics. So Voyager's plasma wave system isn't merely producing interesting sounds. It is functioning as a kind of remote sensor for the environment surrounding the spacecraft. And that becomes incredibly important once you realize how little we know about the space between stars. Before Voyager reached interstellar space, scientists had never placed an instrument directly inside that environment. Astronomers could observe distant regions of the galaxy using telescopes, but Voyager was doing something fundamentally different. It was physically traveling through the material. It was sampling the plasma directly. And every measurement was coming from a location no human being had ever reached before. Even receiving those measurements is an engineering achievement on its own. Voyager 1's radio transmitter produces only around 22 watts of power. That's an astonishingly small amount of energy considering the distance involved. Once that signal leaves the spacecraft, it spreads through space and becomes dramatically weaker as the distance increases. By the time the signal reaches Earth, it is incredibly faint. NASA can detect it because of the Deep Space Network, a global collection of enormous radio antennas designed to communicate with spacecraft across the solar system and beyond. The major stations are located in California, Spain, and Australia. Their giant dishes continuously listen for extremely weak signals coming from distant spacecraft. Some of these antennas are about 70 meters across. That's comparable to the height of a large building. And even with these enormous antennas, Voyager's communication rate is painfully slow by modern standards. Data comes back at only around 160 bits per second under favorable conditions. Compare that with the internet connection you're using to watch this video. A modern smartphone can download information millions of times faster. Voyager, however, doesn't need speed. It needs endurance. Every scientific measurement it sends home represents another tiny piece of information collected from a region of space where no other human spacecraft is currently operating. And this is where the story becomes even stranger. While Voyager was still inside the heliosphere, it was surrounded primarily by the solar wind. The solar wind is a constant stream of charged particles flowing outward from the Sun. The plasma in that environment has its own characteristic properties, and Voyager's instruments detected relatively low-frequency oscillations. But after Voyager crossed the heliopause, everything changed. The plasma surrounding the spacecraft was significantly denser than the solar wind environment it had previously experienced. The frequency of the plasma waves increased dramatically. Scientists could actually see the transition in Voyager's measurements.